Hello dear friends, welcome back on the tutorial from the CAD-CAM from the Enix. So today we will see the how to obtain the planar mill and the profile milling, and this is our the product. So in the first step we will make the milling operation on this surface using the planar milling, and after the planar milling, we will see also the profile milling in order to remove the remaining material after the planar mill on the this surface of the this pocket, that outside part of the this pocket. So this is our the model, and also in addition we will see the how to optimize the tool path in the profile milling. So we will see in this tutorial the first option. In the further tutorials, we will see the other options how to optimize the toolpath in the profile milling. So let's go to the manufacturing environment in order to do this. Select application, and here select the manufacturing. So our manufacturing is still loaded. Now we are here. You can go here just for the manufacturing navigator or operation navigator here. As a first step, as usual in the case of the operation in the manufacturing environment, we have to define our the workpiece stock values and as well as the machine 0 point. In order to do this, you have to select here the geometry view. It is selected in my cases. So here you see two options to select the machine 0 point and the workpiece. So let's define for the beginning the machine 0 point. So here double click this icon, and here our machine 0 point is here. Our the coordinate system, dynamic coordinate system is obtain open it, and you can define the machine 0 point as you want. Any point, just putting the points here. Let's keep it here. So this is our z-axis, y and x-axis. So let's keep like this and press OK. So this is our the machine 0 point, so the reference point. Now let's define our the workpiece and the stock. In order to do this, double click this workpiece, and here we have the geometry. So you have to specify the part and specify the blank. So the two important parameters in order to specify the part. So select here this icon, and select your the workpiece. So it is the selected the workpiece, so press OK. And you can see here by display to see your the work. Now is the next step is to specify the blank. So in order to do this, select this one, and from the type you have several options to specify your the blank geometry. So in this case we will use the boundary block, and here the boundary block is created. Now we can make some changes. Maybe no. Here let's make the z along the z positive, along the z is the 0, so it exactly fits with our workpiece. And make the along the x and along the y is 2 millimeters in the both negative and positive direction. So this is the 2 and 2 millimeter, and the same way here you can see along the y is the 2 and so on. And the keep is the z value is the 0 and 0. So this is our the blank geometry, and press OK. So you can see your the blank geometry by display here. So this is our the blank geometry. We defined our the workpiece geometries, and here we can define the material for the workpiece. By default, this is the carbon steel, and you can select this icon, and you can select any material from this list for the workpiece. So now let's keep it is the carbon steel and press OK. So we defined our the 0 point, our the workpiece and the stock values. Now we go with the operation. Before the operation, since our the operation is the planar milling, so in the case of the planar milling, we will use the most cases end milling with the flat nose. So let's create the tool for this operation and mill. So in order to do this, go here the create tool, and here you will obtain this icon in the window, and we will create here the mill, this and mill, this type of the mill, and here you can define the name of the mill, and I will write here the, for example, the mill with the diameter of the 10 millimeter, and press OK. And here the tool is displayed here, demonstrated, and with some parameters, and let's change the diameter from the 30 to the 10 millimeter. So this is the tool, and here you can define the other parameters. Now we will keep it as default like this, and you can here put the numbering for your tools. Let's make it tool number 1 because it is important to define the tools. So, and here you can define as usual the tool material. By default is the high speed steel, and you can select this icon and define any type of the tool for this tool material. So let's keep it as a high speed steel, and the same way you can define here the shank, the holder, and so on. You can by the just display the shank like this, and you can create the holder by yourself, putting the values here, and or you can create the holder by the library. From the library, in order to do this, go here the library, and select this, retrieve the holder from the library, and this is our the milling operation. Select the milling and just press OK, and here you can press OK to see the list of the available holders for our the operation. There is several operations, so the holders you can display it, see, and for example several holders you can select in the library. Let's select this one and press OK. So we created our the tool holder, and the shank as well. So now press OK. In order to see the tool, you can go here the machine tool view, and this is our tool which we created here with the diameter of the 10 millimeter. Is the end mill. So if you want to change the value of the tool, you can double click this one and go to the tool, and you can change the diameter of the tool. Let's make it 6 because we have to remove this material here, and in this case with the tool diameter of the 10 we couldn't make the proper milling operation, but with the 6 we can do this. So I changed it to the from the 10 to the 6 millimeter. So we created our tool. Now it's time to create the operation. So go here to create operation, and we will see today is this one is the planar mill. So it is used for the roughing operation. So it uses the planar cut level. So the axis is in the along the z axis. So for the mostly is used for the roughing operation. So after that is a planar mill, you have to use other operation like the finishing operations, so on. So here I selected my tool and my the operation. Now in the location, it is the inside of the program tool. We will use the tool here. Unfortunately it's not changing, don't worry, we will change it here. So the geometry is the workpiece. It means that we will define it our workpiece. So and the method is the for the planets rough operation. Here you can define as well as the name of the operation. Let's keep planar mail and press OK, and you will forward it to this the window. Here is the important thing is you have to specify the part boundary and you have to specify the floor. So these two important input parameters for the planar mill. So let's specify the part boundaries. In order to do this, select this icon. And here selection method, let's make it as a curve and select the boundaries for the course. In this case, our the boundaries are this uh, corners, so edge of our the rectangle. So this is our the boundary, and this is our the closet. So you can make it open or closed. Since our the system is closed, we will make it closed. And the tool side is in our the cases is the will be the inside. So because this boundary is here, and that we want to remove the material the inside of this boundary. So that's why the tool side is will be the inside. It means that the tool will be the inside of this boundary. And here the plane you can specify it, but let's specify the plane is the upper plane. So we would like to make the upper plane this one. So from the this plane we would like to remove the until this plane. So here we created our the boundary. So now this is the outer boundary. So in order to create the inner boundary, you have to here we have only the one boundary closed. In order to create the second boundary for this operation, here you have to add new set. So the new boundary is created. So we have to define the boundary for this. In this case, the boundary will be this edge. So here, go here and select the tangent and select this edge. So you see, it is the directly selected all the edge of this pocket. In this case, it is the material will be the outside. It means that the tool side will be the outside, since that we have to we want to remove the material which is the outside of this boundary. That's why here it's important is the tool side will be the outside, and the plane it's specified the same as the previous one. So here you see we have created two boundaries. The first boundary is this rectangle, it's the outer boundary, and here the material is inside. It means that we would like to remove the material which is the inside of this boundary. And from the list two we can see the second boundary, which is the boundary of this pocket with the rounded edges. And here is the tool side is the outside, means that we would like to remove the material the outside of this boundary. It means that these elements. So now we defined our the part boundaries, our the borders. So press OK. So to see the boundaries, you can display it. You see there is the two boundaries. This is the outside rectangle, and this is the inside boundary. And between these two boundaries, so we will remove the material. Now next important parameter is to specify the floor. Here select to specify the floor, and the floor is obviously is this one. So we would like to remove the material until this face. So this is the floor. So press OK. So we defined our floor. Now here is our tool is 10 millimeter, but let's change it. So edit it. So it is the okay. It is edited, but the name is the 10 millimeter. So don't worry. So here the tool axis should be there along the z-axis. So our the method is the roughing operation. So after this we have to make some finishing operation as well after the plane milling. And here you have to specify the cut level. So cut level, go to the cut level and make it is the 1 millimeter. So every 1 millimeter will be the cut level. So now let's see that here most used one in the for this case the follow part or the follow periphery. So let's make it follow part and make let's generate the toolpath. So you see this is our the toolpath. So we define it. So we'd like to remove this toolpath. So you can verify it. So here select dynamic and just play it. So you see the simulation. You see the material is removing every 1 millimeter. So using the tool path is the follow part. So you can speed up the animation speed to see the final result. You see, since this is the roughing operation, here the material is removing on the walls of this rectangle, this pocket. So we will use another operation to remove these materials using the profile milling. Unfortunately, you see here the material is remained on the outer surface, outer edge of the rectangle. So here the issue is this one. So now we will see how to optimize the tool path directly to remove the remaining material on the edge of the rectangle. In order to do this, go here the specify the boundary, select this icon. And here we have the two curves, two boundaries, the outer boundary and the inner boundary. So this is the outer boundary. You see, it is the demonstrator. This is the rectangle the outer boundary, and this is the inner boundary. So now we will change some parameters in the outer boundaries in this one, so in the rectangle. And if you select this one, if you select this one if you select this one, here you see in the list, you see that there is the members. This is the 4 members. So if you select the first member, you see this is the first member, and it is this called here tool position is the tanto. It means there is a tangent, and you can change it from the tanto from here to tool position to the on. So it will be the exactly on the this tool position will be on the this space. So the same way you will have to change all these members from the tanto to the on. So let's go here, and you see it is the changing. Select the third member and select to the tanto. The same way for the fourth member. So this is the member. This is the first member, second member, third member, and fourth member. So we changed all the tool position from the tangent to the on. So in this case, we optimized the operation. Press OK. So since we changed the parameter, so we can regenerate the tool path. Now you see the tool path is changed. So the position will be exactly on the edge of the corner, the rectangle. In this case, we will remove all the material. To see this one, you can simulate it. Now you see the material is the machining in all the edges. So just we changed the tool position from the tangent to the on. So now we removed all the material. Since we have the stock, which is a 2 millimeter here, it is still remained because we only removed the material until this surface. In the next tutorials, we will also see how to remove this stock values 2 millimeters. Now, as a next method for the cases, now we will let's see the result again. Just big clarification. So generate it. Let's speed up. Here you see the material is remained still on the surface of this pocket. So in the lateral surface on the profile, since the method was the roughing operation, planar mill roughing, so materials remain here. In order to do this, we will use another operation. It's the finishing operation with the profile milling. So we will use the same tool with the 6 millimeter diameter in this case. So this is our planar mill. So in order to create the next operation, go to the create operation, and here you see the planar profile. This is the finishing operation. So mostly used after this planar milling operation in order to remove the remained material after that planar milling on the walls of the such a system. So select the planar profile. Here the location program that use the same tool and the workpiece, and here the method is in this case the finishing. So this is the used only for the finishing operation after the planar mill for the wall. So press OK, and you will be open this one. And the same way, the most important two parameters is to specify the part boundaries and to specify the floor for this case. So first specify the part boundary, select this one, and the selection method, let's make it as a curve here, the same, it is mostly used, and select here the tangent, and select this edge, so all the edge selected, and the material, the side is the outside, since we would like to remove the material the outside of this edge. And here the plane, let's specify it, it's the upper plane, the specify the upper plane, this plane. So, and you see it is the, let's keep it tangent, the tool position, press OK. So next important parameter is to specify the floor. So they select this one, and the floor is this one. So press OK. Since here the tool is the tool is this one with this tool axis Z, and our the method is the finishing. So the part stop is the 0, since it's the finishing operation. It means that we will remove the all material, and the cut depth you can define as a constant, the floor only, and so on. Let's make it constant, and the cut depth is the constant every 1 millimeter. So here there is no any the pass setting for this one, because this is only the profile milling. It directly make the profile the milling, so you regenerate it. So you see only the tool path is created along the tangent to the surface of this pocket. So to remove the remaining material, so verify it. So here we can decrease a little bit our the speed animation and play it. So let's see one more time. You see the material is removed on the outer surface of the pocket. So this is the tutorial for today. So we made the planar milling. Here planar milling, how to use the planar milling and define the boundaries, and profile milling. So this is for the roughing operation, and this is for the finishing operation after the planar milling. So on the next tutorials, let's say regenerate it here. On the next tutorials, we will see how to remove this inside material using the planar milling, and make some finishing operation with the walls and floors, as well as we will see how to remove these materials. Say here the pockets is the circular pockets, rectangular pockets, and as well as we will see how to remove this material, the stock value on the outer surface, which we defined at the 2 millimeter in the outer surface of this rectangular element, to see using the profile milling. So this was the all for today, and we analyzed how to optimize the tool path, and also we will see the other options how to optimize the tool path in the such a cases when we remain at some material on the outer edge of the workpiece. So you can save the file for the further tutorials. Thank you very much for your attendance, and see you on the next tutorials.